right? That's good, okay?
Yeah.
Perfect. Are you frequently here at the bank in Lisbon?
Oh, I'm sorry?
Are you frequently here in Lisbon, or are you mostly in Porto?
Mostly in Porto. And I'm not even going to Lisbon lately.
You want to say hi? No, you're joining as well. Yeah, everything is good. Yeah. Thanks for checking.
So, Julie, you are the only one who came after all to Lisbon.
Yeah.
Not even I did.
Yeah. Maybe I
You
should
got
take
nice
a
weather.
photograph from the view that I have here and at this office from Lisbon, which is super lovely. I mean, it's already very nice to be here in Portugal, just for the weather. It's in Germany, it was pretty cold. We had a lot of snow, and here it's sunny.
Believe me, we took care of everything to make sure it was going to be great, you know. Even the weather. But then okay, I think we are ready to start. And so the next presenter is Julia Cloos, right? I'm hoping I did it right. Julia was kind enough to she collaborated with us 2 years ago, where she presented some really nice interactive tools, work with R, and she belongs to this generation of young researchers that are teaching others how to have good habits. And I'm really looking forward to see what we can learn from Julie. She always brings new stuff. And I know in the meantime, she even produced a new package in R that's directed towards reproducibility. She's been working, that's one of her big areas of interest. And Julia, if you don't mind, then we'd like to see your presentation. Thank you so much for being with us.
Yes, thanks for this brief introduction. So I'm going to talk a bit about R Markdown. I've been following the chat, so I realized that this has already been touched upon as a framework for authoring in science. And then I will basically also speak about how it interacts with Pandoc and Lua and how this can be exploited, especially for scientific use cases. Okay, so first I cover a bit, very big, the basics of literate programming. Then I present a very basic, simple PDF manuscript as we would normally produce it when we rely on the built-in tools and our Markdown, and also simple HTML report. And like by showcasing these two simple cases, it becomes clear that there is also from a scientific perspective a great value, and also integrating really interactivity, which is normally preferred or focused in HTML reports, and a submission readiness, right, which we normally focus on when we craft PDF manuscripts. And then, so that's also the idea of the little very basic package that I wrote. And then in the end, I present some of these things. So a few words about myself. I hold a PhD in political science. You might wonder what got me interested in reproducible report generation. Well, I would say 70% of my work relates to data, and then 30% to getting manuscript really also published. And then, of course, some extra 20% to teaching, and probably to get that number a little closer to 100%, I decided to make my own life easier by making workflows easier and smoother. So that's why I wrote this reproducer R library. And I think literal programming, reproducibility, and open science are key in academia. That's clear in this workshop, and that's also why I was motivated to write the package. So when we think about narrative text and code integration, we basically think about executable reports, right? So we have the idea that our code can be embedded in narrative text or documentation. It can be both. And the code should ideally also follow the structure of documentation. Ideally, we also want to integrate, and that's also been touched upon in the chat, a little narrative text and code in really multiple programming languages. For instance, R, Python, or Julia. And we can do that. Our Markdown is able to do that, even to some extent integrates data. And ideally, we would also like, and that's something I focus on, to be flexible to produce different types of research outputs by relying on the same code, right? We don't want to repeat ourselves. We don't want to copy paste. If we turn our paper that we have just published into a blog post and we want to showcase some of the figures there, right? We don't necessarily want to copy and paste all the code from one our Markdown file into another. So that's why basically I suggest, or it can be beneficial to write code in the first place, that it is also flexible for different output types. So that it's either static, it can either produce static tables, graphs, figures, or dynamic and interactive. So Markdown in general, as the Markdown syntax is so advantaged because it's human readable, it's a lightweight markup language. So we know how easy we can format text when we rely on Markdown. We don't have to rely on very heavy LaTeX syntax to achieve, for instance, bold formatting, italic. Neither we would need to add a lot of code to introduce sections or lists. So we wouldn't need to begin an item, itemize, and then include our items. We can just start typing the list. These are big advantages of Markdown. And the same goes for links that can easily be inserted by simply putting them in brackets, and the actual link in simple parentheses, and then images can be included following the same logic. Line breaks, this is something that people who start working with Markdown or relying on Markdown when writing their papers frequently struggle with or don't know. It can be achieved by relying on two spaces after a line. So how does Pandoc come into play here? Well, Pandoc is a document conversion tool. So it is free and open source. It's widely used as a writing tool. And basically, Pandoc uses an enhanced version of Markdown, which is called Pandoc Markdown. And that offers, it is an advanced for tables, footnotes, citations, and math, all of which are critical in scientific writing. We basically set up a Pandoc document, a Pandoc Markdown document, by relying on a YAML metadata block. Of course, this could also be a YAML separate file, but frequently we also keep it in one document, at least if it's not too big. And we delineate this YAML metadata block with 3 dashes. and that basically sets the global parameters of a document. In actual Pandoc, this YAML metadata block can come anywhere in the document. Unfortunately, this is not the case for Markdown. Our Markdown really expects it in the very beginning, and it can't handle some extra YAML metadata that comes in the middle of the document. So, but in theory, Pandoc is more flexible than our Markdown, so in theory, it can come anywhere. When we now think about Pandoc Markdown, we can also think about other things that are very useful for us as scientists, for instance, citations, which we frequently want to include. CiteProc is supported by Pandoc, and it basically helps us to easily format bibliographic data, and we can do so very easily by relying on the formatting instructions that are included in certain citation style language files, CSL files. And these files we simply add to our YAML metadata block in the beginning. We can, if we compile the document while we have internet connection, we can even copy the URL, so we don't even have to download the CSL file locally to our machines. And that basically formats automatically all of our citations according to the citation style language. Basically, this is here an example of how you could do that. I actually integrated a CSL file that is from a link, from a URL. And then how would you go to cite these things in your report or in your manuscript? So you would include inline citations by simply typing, and that basically is the key. So here in my literature bib file, that is how I gave it. That's the key, the bibliographic key. So I simply add an @ and then reference the bibliographic key. Or if I would want to include the citation at the end of a sentence, I would put them in bracket and reference the page number. Another thing that can be relevant or is relevant here in the context of this flexibility regarding the output formats are the so-called div elements. Div is basically abbreviation for division, and basically Pandoc can understand such different elements of the document, and it can understand to apply certain filters to certain divisions or to exclude them, which we will exploit in our case, where certain elements will only be included in our reports if they are if they are meant to be rendered as HTML reports, whereas others will only be included if they are meant to be static files that we actually want to submit. So this would be if we were to define a special div, for instance, that is colored red. That is something that we could easily do, and then we could basically make Pandoc understand that. Okay, our Markdown is an authoring framework for data science. It's basically, the idea is that you can rely, if you wish to do so, on a single file to execute code. And basically the document code flows, so there's no out of order code execution, at least if you render the full document. Of course, if you click on the individual chunks and execute them, you can also execute them out of order. It's meant to produce high quality reports in different formats. So basically takes this idea from Pandoc, and that can also be shared with several audiences. It's also quite flexible. It's not as flexible as Pandoc. It comes with some restrictions because, and we'll see that in a second, knitr also plays a role when we think about how our Markdown converts by relying on Pandoc. So the narrative text is written in Pandoc's Markdown, and then basically it's translated to the actual file output. At the same time, all the underlying code, be it our code or the code in another programming language, is executed when we render the report. So these code chunks, how do they look like? They are introduced in the document in the actual R Markdown, which ends with RMD file extension document, by 3 backticks. And then it opens here. I call the engine R. I could also call other engines if I had set them up. I will show you in the example, like a very simple example to call, for instance, the text engine, which we could use to produce figures or graphs. And if we were to render the document to a LaTeX document or to a PDF in the end. And that's a name that I give to the chunk. I don't have to give name to the chunk, but it's a convention to do so, and it helps also tremendously to navigate through different chunks. And here I set some other code or chunk options, and these refer to the placement of the figure in that case. And here in that code, I do nothing else than basically calling knitr and relying on the built-in knitr command to include a figure. So code chunks so basically control how the code and its products appear in the compiled report. And like relevant chunk options we frequently use are, for instance, eval. So this is Boolean value that decides whether or not the code is evaluated. Include, it goes the same whether it is evaluated but not necessarily included in the report. And here results is, for instance, something where we can determine whether we want the results to be presented, to be shown as they are, or basically in a different format. That format would then reflect the output format that is chosen, so that the global one. So there is also a comprehensive list, and the idea is really you add unique names to your code chunks. So how can you then reference actual code output? Because that's a key idea of literal programming, that we don't basically, when we write our narrative text, that we make reference to what we show or what we have computed. So if we think about a simple linear regression model here, this would be a code chunk where we have this, where we come up with a speed estimate, and that's a coefficient. So this object I create here by relying, so I use the tidyverse framework. So basically that's how I extract here the estimate of this regression. And then in my actual document, I would simply type, I wouldn't call 3 backticks, because whenever I reference R code, whenever I want to call the R engine in line, I just use a single backtick. And then I write a short sentence, the estimated coefficient is, and then I call R, and here I use another built-in R function. I round the estimate to 2 digits and print it. And that is actually the actual output. So this presentation itself is R markdown based. So this is not a copy paste that I put there, but this is actually the real output. So this would similar work if this document would be a manuscript, right? So what is then like how does this all come together? So what is the magic behind the scenes? Well, there is actually not so much magic. We start with this R markdown document that I've already mentioned, where we integrate our code and our text. We write the text in simple markdown, and we add the code in code chunks. And that where is the first step, where knitr comes in, and knitr transforms this to a markdown document, so a simple one. And here Pandoc is the actual workhorse, and that framework behind it, either depending on what we tell it to do, renders it first to a text file, and then also PDF LaTeX or XLaTeX or whichever engine we use, renders to PDF. Or we basically compile directly from the markdown to HTML, and that's basically we tell Pandoc to do so. And what I like highlight in the little package that I have developed is how powerful we can basically adapt this framework to our needs as scientists and as scientific writers in the end, if we add a couple of Lua filters, right? So we can basically, so the package that I wrote is nothing else than it relies on all this existing framework, and it adds some very relevant Lua filters that, for instance, help us to put some of the parts that we would normally have to put in the YAML meta block into our actual document, which can be very useful because the document, in a sense, is what we as authors create, whereas the YAML document is just the global parameters that set the structure. So, for instance, it moves the abstract from the YAML header to the actual document. Or it helps us to include 2 section references. So one section with references at the end of the manuscript, and another one, because we usually have very long appendices, at the end of the appendix. And depending on which citations we include at which point, these different reference sections, so bibliographic sections are called. So these are some examples. There are also some others. Basically, one other feature that I think, at least in political science, is very powerful. I assume it's the same for economics. Is that it, like by introducing another filter, it helps you to automatically blind the manuscript. So basically, you just change one parameter in the YAML header, and then you get a blinded version of the manuscript that you can actually submit. Right. Okay. So let's. I'll briefly switch to my to my RStudio, which you should see now. So just to showcase this a little, so here basically I set up a super simple R Markdown PDF document. Here you can see these three dashes that really delineate the YAML metadata, the block. And then I don't rely on the very base version of the PDF version. If I were only to rely on, so if I would specify as output format only a PDF document without relying on PDF document 2, I wouldn't be able to cross-reference within the document, which I mean is essential, right, in scientific writing. And I specify some other global parameters. For instance, I personally, sometimes you run into issues. So I always keep this option, like into the issues that you have to fix. I always keep this option to keep the tag file that I have just shown you is rendered in the process. And I always specify that it should be kept as an output, because sometimes it's useful for debugging. If like at the last stage, at the conversion stage from tag to PDF, something fails, I can easily debug this if I have a look at the tag file. Or we, like in the chat, there was a discussion about the requirements that some journals require you to submit the raw tag file, which I think is useful. It also helps us because we have an easier time when we get to read the proofs. Things are already formatted correctly if we submit the tag file. And so that also helps, right? So here in the beginning, this is the first chunk. It's always a setup chunk, and I use Pacman as a package manager. And here I basically just like call the packages that are needed. I also specify some global knitter options that can be helpful, so you don't have to specify them in each chunk individually. I rely on a specific font that basically I call with the show text package. That's how it's called, and I load some basic dummy data. And then, so this is more or less how you would just write your manuscript. Here, this is basically the section 1 header. This is a section 2 header. And here you can also see some examples for citation, how you would include images. I have the option to click, and that's what I just did, and what you saw on this button to knit the document. So this is not something, I mean, this is very GUI-like. No, we click on something and it renders something. If people prefer to work from the command line, you could arrive at the same output. If you were to type R Markdown, you would call R Markdown and would type render and reference this exact document, right? And we'll see in a second that if you would specify several output formats, because that's what I have argued is in a sense the goal, or is at least beneficial in saving us some time when we prepare our data or our analysis for several outlets, then basically that can be helpful to also work from the command line, where you can actually also specify whether it should render to both formats at the same time or one after the other. Okay, so it takes a while, and that's actually what we're left with. We basically see here the report. I saw there was a question in the text, but a question in the chat, but I couldn't follow. It was related to. It's a bit difficult to follow the chat while speaking. Well, maybe we can also.
We'll handle questions at the end, Julia.
Yes, excellent. Okay. So here we include graphs, like ggplot is the most powerful framework to relying on graphs in R, and some tables, so tables, the powerful framework to rely on to create tables is Cable, and in conjunction with Cable Extra. And then like for regression tables, it's a very powerful and I think up and coming packages called Model Summary. That is also very flexible regarding output formats, which is what we are interested in. Okay, so these are basically the basic things. We can briefly no, I think we'll do that later. So let's look at the same thing, at the same objective now, but from the perspective of an HTML document. And like when we think about an HTML document, I mean, there is always a reason why we use HTML. And some of the reasons why we use HTML is that we can either share it on the web or we can integrate powerful JavaScript libraries. And that's actually also something you can do without knowing JavaScript, simply by relying on JavaScript libraries that have been wrapped into an R package. And I'll show you some of these examples in a second. I mean, these are like basic versions. Like on the one hand, for instance, I animated the ggplot that I just showed you, this basic scatter plot, by relying on the ggiraffe library. So this is also an HTML widget where you can then like specify how basically users should interact with your graph. So that's something we are all very familiar with, and when we engage with data on the web, is that we can in a sense interact with the data, or that we can learn more about the data. For instance, if we hover our mouse over some of the data points. So here you would see another like use of interactivity. We could rely on Leaflet, which is basically a library that introduces HTML widgets to include graphs in our presentation. That wouldn't be something where we would heavily rely on data, maybe, but maybe it could also be, right? If we were to present, like in my case, in the case of political science, if we were to present, for instance, data from voting results at the precinct level, for instance, it could be very powerful for you to explore the data, but also when you give a presentation to show that, right? So you would normally add you would normally put maybe a small version of that map in your paper, or show some of the voting data in a geographical way by including a smaller image. But if you give a talk, if you give a presentation, it's also super meaningful or helpful for the audience to see you engage with it and basically contextualize what your claims. Another use case where you can profit from interactivity are, for instance, tables that you create with DT. It's another JavaScript-based library where you can basically allow yourself, but also the audience, to engage with the data that you have without putting up a long table, right? So you could, for instance, say now, okay, these are penguins. Let's just focus on those penguins that are female, and let's include those that have been observed in the year after 2007. And it would automatically filter the data for you, show you basically how many entries there are. So these basically, this is the JavaScript library that relates to this. Is called data table, and that's why hence the abbreviation DT. Okay, finally, here the example that I mentioned before about the animation of the graphs. So here we can hover over something and explore the flipper length. It could also be something even more powerful, or more like, let's say, something more substantive. The flipper length we can already grasp from the x-axis. So it could be something that we add a third dimension that is not even included in this graph. So this is the idea. This is just to, in a sense, convince you that there are certain elements of HTML output formats that are incredibly useful for us as researchers. And then let's go back to my presentation, which I think I lost for a second. So I'll briefly, it's not computationally intense, so it will quickly recompile. So now the idea is, so we are basically, we are there, that we understood, okay, there are enormous, tremendous benefits from both output formats. But now the idea is really to see whether there is something that we can do to actually integrate these two I think I should maybe, well, I can also, I'm sorry for this interruption. It was I was not being patient and trying to make the process easier. But I think it's easiest to just wait for a second. So the idea is really to see whether we can combine these two elements, and I can anticipate that we can combine these two elements and find a smart way to basically rely on this existing framework and just add a little, add some additional features to it and add some additional, in our case, Lua filters, and exploit some of also the knitter built-in conditional evaluation of code to really maximize this for our needs. Okay, we're back, I think. Excellent, perfect. Okay, so that's why I was interested to generate an integrated file solution, and I've created this very basic library which just adds these Lua filters. So it builds on the existing Markdown, but extends it for a more flexible use for scientific use cases. What is a Lua filter, or how can we understand it? It was already included in the previous graphs, but here I show you an example of a Lua filter that we also integrated in our documents, which is basically, it's a filter that kind of evaluates code only if it is HTML, right? So this is the abstract syntax that is included in abstract syntax tree that is included in any of the Pandoc documents. And if you apply a filter in between the parsing and the writing phase of Pandoc, this filter is applied and adds this new abstract syntax tree. So these are the basic ideas. It wouldn't, in our case, in that example, affect the PDF, but there are other filters that could also affect the PDF. So then in that case, if you rely on this library that I have created, or you can also create your own library and add other filters, what you would do if you would specify this document is basically that you would modify the YAML parameter and specify two different output formats. And then you could either render to one specific one or render to both each time you render the document. So, and you could do that, for instance, by like command line calling first our Markdown and then calling the render command. You could also, if you prefer this, to click on the knit button in the RStudio IDE. But then our Markdown, that's important to note, will always compile your document to the first output format that you specify in the YAML header. So if you specify several YAML headers and you rely on RStudio IDE as an IDE, there will be a small arrow next to the knit button that also allows you to switch to which exactly formats you want to render. But in some other IDEs, for instance, you could also render our documents if you there's a plugin in PyCharm that you could use. That's not the case. So that's good to know. It will always render to the first that you mentioned by relying on this knit button. So the idea is you have the version is that you, or like automatically default in that package is that you include your code with code folding automatically for HTML output, and you hide all of your code in PDF output. So then basically what I hope this package offers is that you have a polished and well-formatted HTML that is also optimized for scientific use cases by, for instance, automatically, if you specify, including your ORCID. And you also have a polished and circulation-ready PDF report. So how can we tell our Markdown which parts are explorative or drafty or interactive, and which parts are meant to be in the final report? This is basically where the Lua filter comes in, and where we can add now, just similar to how we added code chunks, we can add specific elements to our document where we specifically specify Pandoc not to evaluate anything or not to write anything if it's in a specific output format. So we would do that by calling these phi colons and then opening these curly brackets and then specifying this not in format, and then we would specify LaTeX, for instance, and we would close it by 3 more columns, right? So that's as easy as it is, and it's very powerful, especially in conjunction with conditional code evaluation. So here is the DT, the data table, the interactive data table that I showed you before, where we could now specify, okay, this data table is of no value in our static PDF document. We have better tools, better libraries to generate static tables, and we could specify, okay, this shouldn't become part of a static report. We would do so by calling these colons and combining it with a conditional evaluation of the code that basically it is also a Boolean value that comes out here, but it's not a fixed one. It's not false or true, but instead it's something, it's a value. So the value comes after by calling knitr first, right? So knitr is asked. We could say, is this document meant to be an HTML? If it says no, it's not, the value turns false and the code is not, the chunk is not evaluated. If instead it is, it turns true and the code is evaluated. That's basically the idea. And so this is how you could integrate both elements within one document and then be flexible up until a final point without having to repeat yourself. So then you can rely on these tools that we have already mentioned. And I think like another feature that can be very nice is that I specified also a little function that actually relates to how the document is knitted, and that is basically it relates to how you would render the static version. So that could be text, that could be, or the PDF, that could be the HTML. You could add a date stamp to it while keeping a clean version of your code or your narrative text and code. So your IMD file that you can actually track with version control, and then render different static versions of the document that could, for instance, include a date stamp. It also helps you to really be easy to harmonize your fonts in the graphs that you use with respect to the different output format, and generally the default is not as it is in R Markdown. The default in basic R Markdown is to create very low resolution graphs, and here the default is to create higher resolution graphs. I already mentioned that you can include separate bibliographies, which I think is very relevant, at least in my discipline. And it's also, I have briefly mentioned this, optimized for scholarly writing. So the idea is you can include more information about authors. You can add multiple affiliations, all of which isn't possible if you rely on basically the tools or the options, the placeholders, so to say, that exist in the basic version of, or that the placeholders that the basic version of Pandoc understands. If you rely on the YAML block. I mean, you can play around, you can add multiple authors by, for instance, abusing the date field for that, or the thanks field. You could also abuse that, but that's not very nice. And at some point it gets a bit tedious to write a lot of, like, for instance, LaTeX raw code or HTML raw code in the YAML header. So, and I already mentioned that you can also blind your manuscript by simply changing one parameter in the YAML header. And that would like result in these like two different versions of this paper that you see here, which is one includes all the institutional affiliation, and the other includes the title page, which is also something that is frequently required when we submit papers. We need a title page, and then but it's blinded. So I think the package template also features other examples, and I will also share with you one other document which we can just look at that I have prepared for this workshop. So if you would download this package, which is currently not on CRAN, it might be soon, I hope, is basically, so you would need it to install it from GitHub, and then you would create basically a document from template, you would say, and look at the reproducer here. And that also gives you some other opportunities to explore it. And now we can go. I think we have time, not so much. We should maybe focus on the questions. Paulo, what do you?
Yeah, sure. I mean, in the meantime, there were several questions posted, and some of them were answered too. So. But before I move on to some of these questions, let me just make clear, because I am not an R user, yet I have just recently tried to use R Markdown to prepare a presentation. I was very impressed with the outcome. So would you say that you can actually get enough control over a LaTeX document that you could make it in R Markdown? Suppose if you want to submit it to any journal, will you feel comfortable just to do it everything in R Markdown? I'm just curious about this.
Yes, I have changed my workflows. Yeah. So since years, I do it in that way, and I didn't have problems. I mean, yeah.
Okay.
I think some of the others were also kind of sharing my my optimism that it's basically you don't lose anything, you don't lose the control, because I mean, I don't recommend that, but if you are really frustrated and you can't get like a certain table to look like it's meant to look by just relying on R code, you could, or you're always free to include raw LaTeX, but that basically ruins your flexibility. So that, like, if you include raw LaTeX in your code, that's why I would also say I wouldn't recommend it. Then you can't render to other output formats. Yeah.
Okay. Let's handle some questions. I see that we had some.
I can actually not read the questions if I have the screen.
That's why we're here, Julia.
Shared.
We have the question, I think, that is relevant and that might actually be addressed in your package was, how do you actually handle cross-references to figures and tables? Do they work in this or do they not?
Yes, they work, but they also work in a very basic R Markdown. It's conditional upon using the two versions. So there's basically that's the book down package that offers this cross-referencing, and you would basically, as an output format, specify book down and 2 colons, and then you would call the normal document class like PDF document, but you would add a 2 at the end, and that helps you to reference figures. It's very easy to reference figures. I think there are also some examples here in this document. Let's see. Yes, so this is basically how you would cross-reference. So this is basically the cross-reference that you include in your text. And this figure has been called, has been labeled winter. And the chunk that is labeled winter, we can take a look, is simply called winter. And it automatically adds that label. So whenever you include a figure, and knitter automatically understands, okay, that's a figure, and adds that label, fig :winter. So that's a convention, and you can use it for your benefits. Yeah.
Okay, thank you. Very useful. Some folks in the chat had issues with precisely that functionality, I believe.
You had a question too. You want to place it?
About caching. I mean, I did use R Markdown some years ago, and then I had to try to rely on the caching, because like let's say some parts are very, very expensive and stuff. And that was kind of a little bit of a problem, but in some sense, like it feels like sometimes you have to regenerate the whole document a couple of times, and then sometimes I didn't put names on my chunks, and like, yeah, it is sometimes a little bit hard to get to, but it's not that the alternative world is much better. So.
Yeah, the caching, I think, can be a problem. I mean, normally you can, so that's also an option that you can specify for like each code chunk individually, which is a problem, because then let's say, I would say if you use caching, you should use it globally, because then at least you make sure that the order of the code chunks is still preserved, because sometimes we have discussed about seeds and so on. So sometimes this also involves random numbers, and then it's very important what is actually the cache and how is it generated. But then I think it works. So the caching works. I mean, the caching for me personally, I always I never check it into Git. I'm always before I submit, I never rely on the cache. Like before I submit, I turn that option off. But then if some of the computations are intense, are computationally intense of the analysis, then of course it can be very useful. Yeah.
No, I think at the end, what I mean, I have a separate code that generates the figures, and then you include them at the end. You just have like a meta workflow, I guess, in a make file or something like that.
Yes, yeah.
For memory,
yes.
that's actually what I had to.
Yes.
And I think it would be a healthy discussion too, or like a poll to whether people like a Markdown or Weave, I guess, approach versus like a Jupyter Notebook approach. And I have changed camps over the years, so it's they both have drawbacks and stuff. But yeah,
you have changed to Jupyter.
Yep, it's and it's a pure kind of usability thing. I feel like I'm a little bit more productive using Jupyter Notebooks somehow. But I first hated them because
for actual authoring. What do you use?
Oh yeah, no, I use pure LaTeX still today. Yeah. And I fight with horrible error messages today. It's the same way. But I have also used restructured text. I guess is the other option that one could use in Pandoc. But it sounds like nowadays it looks like this has like all the features that you would need. So maybe I have to take a look at it again.
Might be worthwhile pointing out for those who are coming from a slightly different world that R Markdown and Pandoc both also have Word documents as outputs, and so the idea is that you might actually be generating some of these things in a variety of formats, and your nasty journal says, I don't like your LaTeX, I'd like to have a Word document instead. Actually, this is not a bad solution. It's not perfect, but then again, it's journal's jobs to do the copy editing, not your job as an author. And so I would say usually you shouldn't be too worried about being that far away. It's at least to start with it. So it is feasible to output these things as Word documents as well.
Okay, good. Just time for a last question that was put on chat here. If you have any recommendation for R tools to use data directly from a database when in our Markdown?
So I mean, I'm a tidyverse person, so I don't know how familiar people are with tidyverse. Is basically the idea of like functional programming taking to its perfection, I would say. So and like there's a tidyverse implementation of which is called dbplyr, so database plier, and that is actually like to someone who's working with the tidyverse, it's incredibly easy to have a database request to send requests because you rely on the same programming and language notation that you're used to when you use the tidyverse, and then you basically call the database.
Okay,
but I think there are many others. And
I'm sorry.
No, sorry.
Okay. Thank you very much, Julia. We'll move to the next.
One thing that was actually kind of interesting that was kind of discussed is like the fact that when you, I mean, maybe you said it, like when you version the stuff and what can be proprietary data and stuff like this. I think that's, did we mention this again? Maybe I missed it. I think that's kind of something that I've also kind of faced with like literate programming. That is, if you do a plot, which is a scatter plot that maybe has one individual point, but that's not something you're allowed to get out and stuff like that. Does that make sense? And I think someone replied, Sebastian said, like, rightly so, any enclave is going to have to check any output you come out to bring out and stuff like that, which they should do. And usually they specifically check that you have like not a single point, right? But it's kind of like sometimes in the back or in the cache or something. It's even worse, I bet, on notebooks, on the Jupyter notebooks than on Markdown, because at least here, I think it's a little bit clearer what's in and what's not out. Whereas a Jupyter notebook, sometimes they cache stuff and you don't even know. But I just thought that was an interesting discussion because it's...
No, I absolutely agree, yeah.
It's probably the case also for PDF things or LaTeX things. You could always include a plot that has this stuff.
Okay, great.